Today you have been, in discussing the computational model of the mind, you have been emphasizing the biological. But 2 days ago, in discussing Searle's own view, Searle's view that the mental is the neurological or the biological at a higher level.
Not the biological, the neurophysiological.
Well,
there's a big difference. There's a crucial, remember, I'm taking...
Yeah, my question was, could you remind me your reasons against Searle?
Okay. Remember, there was a phrase, which in fact I took from Searle, but it's very common. The phrase is, this says the mental is the computational. I've been talking about that. There's another one, which says the mental is the neurophysiological. At a higher level. There's a third position. So the mental is the computational is one position. The mental is the neurophysiological is another position. And a third position, the one I'm advocating, is the mental, meaning, you know, all the properties that we put under this descriptive category is properties of matter. Probably cells, though we don't know for sure. Probably cells, but that's an empirical speculation, a plausible empirical speculation. Well, this one here, the mental is neurophysiological at a higher level, is a much further speculation. You know, because the neurophysiological is only a piece of the brain. I mean, and if by neurophysiological you mean, say, synaptic connections among neurons, it's even a smaller piece of the brain. And to say that that piece of the brain is what's carrying out and neurophysiology is a particular way of looking at that piece of the brain. There might be other ways of looking at neurons. Like I gave an example, I don't know if you were here at the time, of the study of nematodes. Which are these, were you here when I talked about this? These are little worms. This is the most complex physical object that's completely understood in terms of developmental pattern and wiring diagram. They have 300 neurons. The wiring diagram is completely known, and the developmental pattern is completely known, so they're an interesting object of study. Nothing is understood about what they do. The study that I referred to tried what amount to neurophysiological models, if by that one means looking at synaptic connections among neurons. Tried first connectionist models, just threw them out because they were hopelessly inadequate. Then it tried what, you know, it's a little clear what we mean by neurophysiological, but if we mean what neurophysiologists study, like synaptic connections, it tried that. That didn't work. He then made up much more complex models involving all sorts of other kinds of chemical interactions and this and that, you know, asynchronous computers, I mean, all kinds of crazy models. And with all that stuff was able to come a little closer to characterizing what a nematode does. Well, okay, he abandoned the neurophysiological. That is, you know, we don't talk about the mental in the case of nematodes, but say turning, you know, moving in that direction was not the neurophysiological at a higher level, because the neurophysiological was just the wrong thing to look at. Now, in the case of thinking, it might turn out that the neurophysiological is the relevant level, or it might not. That's an empirical claim based on nothing, except the fact that neurons are there. And you don't make empirical claims on the basis of that sort of thing. I mean, if somebody came along and said, the mental is the vascular at a higher level, vascular meaning referring to blood flow. If somebody said the mental is the vascular at a higher level, you know, everybody would laugh. I mean, the fact of the matter is there's a ton of blood flowing through the brain. Huge quantities of blood go through the brain. Nobody knows what it's for. And so, okay, suppose somebody comes along and says, I think the mental is the vascular at a higher level. That's a joke. I mean, the only thing we have any evidence about is the mental. We're trying to find out what other level relates to this. We look at electrical activity of the brain, we find some correlations, so we assume, okay, whatever's causing electrical activity of the brain seems to relate to this. That might be the neurophysiological, it might not be. I mean, maybe, you know, people like Penrose, who's a not inconsiderable scientist, I might say, one of the best quantum physicists, maybe he's right. when he says there are unknown quantum effects that are yielding mental properties. And we got to look for those unknown quantum effects by changing quantum theory. Well, maybe, I mean, that's certainly possible. This particular empirical assertion is just dogmatic. That's why I would block it. This traditional assertion that the mental is properties of matter, matter being whatever there is, I don't think that's dogmatic. That defines naturalism.
No, that is not dogmatic. That is contentless.
It's not
mental is whatever properties of whatever matter, and
that's right.
The economical, the social, the biological.
No, not at all. It's saying it's individualist. It's saying it has nothing to do with social. It's taking an individualist point of view, saying, look, here's an organism. It's got a particular physical object. It's like saying this kind of object has properties of electricity and magnetism. It's not contentless. It's saying if you want to explain electricity and magnetism, don't look for angels. Look at properties of organized matter. That's not contentless. And in fact, that defines the course of science, post-Newton. The suggestion is, yeah, that's exactly what we should do. It doesn't tell you a lot, that's obvious. It just gives you a course to follow. And the course that it gives you to follow is find the properties, okay, give a theory of the properties, and then search for unification. That is, ask how it relates to other properties. Well, that's exactly the course that I would recommend. Look at the properties that are involved in things like, say, rhyme or entailment or other formal relations. Try to find those properties, get the best theory you can about them, and then see what you can discover about other ways of looking at the brain that'll relate to this. For example, if you discover that electrical activity relates to it, great. If you discover that there are localization results so that sign and spoken speech are localized in the same place despite the radically different modality, fine. If you have aphasia studies that show that some category of structures is wiped out and you know where the damage is, fine, you've learned more. And proceeding in that way, you try to approach the unification problem. But to make dogmatic claims, you got to look at the neurophysiological, because I say so, that's pointless. That's what's wrong with this slogan. What should be said, the way it should be said is, I speculate that the neurophysiological is the mental at a lower level. I so speculate. So you notice that this is given as a definition, and it shouldn't. It should be given as, it's got it backwards. It should be given as a speculation, turning it around, saying, okay, we kind of understand the mental. We have computational representational theories which explain a lot of things. I make the speculation that they are expressions of neurophysiology, even though nobody has any evidence for it. Well, that's a plausible speculation. And in fact, it's the kind of speculation which would lead to a research program. It would say, okay, let's try to find what it is in synaptic connections or whatever that have the properties that these guys discover when they look at rhyme or entailment. That's a perfectly reasonable research program. But the way it's presented is just a dogmatic assertion trying to get rid of the sense of uneasiness that some people seem to have about the properties that are called mental. That was my objection. It's quite different from the, it's quite different from either of the other two positions.